for calling in and joining from all around the world. On today's live call, we have people from Africa, California, Berlin, other parts of the US, and I imagine those of you that are listening to the recording are from all over the world. Hive has members from 125 countries and likely growing, so it's really an amazing global community, and it's such an honor to be connected to you all from all the farthest reaches of this beautiful planet. We have an amazing guest today. And before I go ahead and introduce Reese Jones, I want to invite us all to ground for a couple minutes. So if you feel comfortable closing your eyes, please do. If you're listening while driving, just take care of yourself because you are gifting yourself this hour. There's so many things that you could be doing right now, and you are honoring your inspiration to grow, to learn, to become the best leader you can be by being here. So let's just take this moment for ourselves. Take a deep inhale in. Hold for a moment and exhale slowly. We'll do a couple more deep breaths. So inhale through your nose. Really full inhale. Feel your chest expand. And when you get to the top, hold the inhale for just a moment. And now exhale out your mouth, and you can let go of any stress from the day, any concerns, any worry, just let it out. We'll do 2 more like that, and if it feels good on the exhale, feel free to move your body a little bit. You might want to shake off today's pressures or anything that has come up this week. So inhale deeply. Exhale out the mouth. Now inhale, and you can inhale gratitude or some type of positive emotion that you'd like to feel. Presence, gratitude, joy. And hold it at the top for a moment. And then on your exhale, let go of something. Just one more deep inhale, exhale on your own time, really filling your body. And you can feel your feet on the earth or feel your butt on whatever you're sitting on. Just really feel grounded in this moment, wherever in the world you are. Wonderful. And now welcome to this new moment. It's so good to have you here, Reese. Reese Jones is a truly inspiring man. Reading his bio, I'm almost in awe. I didn't know that somebody could accomplish so much in their short life, and you're still going strong. So I'm going to share a little bit of your bio, and I'm going to keep it short because your bio could take many minutes, because it's really, truly a powerful life you've lived. And we'll also go into your story a bit. So I don't want to take too much time just reading off the paper. So I want to actually hear from you what you've been up to. My name is Charlene Jessica Parker, and I'm your host, and I'm so honored to be here and introduce Reese, who is a biophysicist, inventor, and entrepreneur with over 25 years of work in innovation, entrepreneurship, and patents. As a venture strategist, he has engaged in startup financing, IPO, acquisitions, and venture partnership with a whole list of organizations. He's contributed to over a dozen Silicon Valley startups, including IPOs and acquisitions. He's served on many boards and serves on the board at the Santa Fe Institute and Harvard Medical School's Genetic Council. You're a Lester Fellow in Innovation and Entrepreneurship at the School of Business at UC Berkeley. Reese supports public education via the Singularity University, with whom he is a founding member, Wikipedia, the Shabbat Space Science Center, and UC Berkeley. And that's just the short bit. If I read all of the organizations and companies you've started or been chairman of, it's a very long list, many of which I'm not even familiar with because there's so much in innovation, science, and we can go into that a little bit. So welcome. It's so good to have you.
Thanks for having me. Hi, everybody.
Before we fully dive in, if whoever's here live, I know there's been some new people that jumped on, go ahead and write in the chat box where you're calling in from, just so we can have a sense of our global ecosystem that's here live with us. So we have Danielle in San Diego. You can just type in. Ram, I see you might be driving, so do your best to use the chat box during our call. There'll be a couple times I might ask you guys to engage live, and I invite you to be fully present because I know that Reese has a lot of wisdom to share with us. So to begin, I'd love to know a bit about your story. How did you get to where you are now? What brought you to the projects that you're currently working on? Give us a little sense of what you've been up to for the last 25 or so years.
Well, I grew up in Silicon Valley, and my dad's a professor in the med school in San Francisco. And so I was in the middle of both medical biotech and computer tech, sort of the culture of San Francisco and Silicon Valley. And so these convergence of biology and technology is natural for me, and something that has been progressing through Silicon Valley for decades. And so it's something that I've been observing and participating in for a long time, both on the technology side, but also on the biomedical side. And so the thing that I studied in school was biophysics, and I was planning to be in academic research my whole life, doing brain research on what's wrong with the chemistry of the brains of schizophrenics and versus normal people, and using brain imaging techniques to measure that needed a lot of computers to analyze that. And then, of course, it was people on the other end. And so combining those two things has long been an interest of mine and what I was planning to do. And then while I was in college, my hobby was phone hacking. And that was something, to me, very interesting, that the global phone network, or now the internet, is probably the most complicated thing humans have invented, and it's also evolving. And so phone hacking in the early days was essentially prodding that system from the outside to try and figure out how it worked. And so in many ways, it was sort of like brain research. It's just the brain was the internet and not a person. And so the learning about phones and how phones worked and how the parts of phones worked, I ended up when computers first came out and networking was first developed, I ended up using phone parts to hook the computers together, which at the time was radical, or that computer networks were designed by computer engineers who were taught electrical engineering in a certain way, and designed the networks with very conservative approaches. And I was trained in physics and non-engineering, and so I wasn't taught that certain things were supposed to be impossible, and didn't know they were impossible, so I just did them that way because it made sense for me, and it made sense from a physics point of view. And it turned out to be a much better way to hook together the computers, and that's evolved into that blue wire most people are familiar with, that many people call Ethernet today, that attaches your computer to the wall, that attaches most computers to the internet. And that was kind of a distraction. That was my hobby that sort of led me in that direction. And so I got distracted into building products for people to hook their computers together in that way. And my hobby turned into a business, which got me distracted out of grad school. And so I took a leave of absence and to pursue that, and that turned into multiple companies that grew and went public and so forth. And so I kind of grew with the internet, but I've always had a grounding or an attachment in biology. And my academic interest was biophysics, which is combining or using physics to describe biology, which is sort of dry analytical stuff to describe wet, squishy stuff. And so that discontinuity between something that is organic and biological and flowing and so forth, trying to use the language of physics to describe such things is something that's always been an interest of mine. and that continues to this day. And the other thing early on is we were using phone wires to hook together the computers, and phones, of course, carry sound. So the logical thing to do was to add the sound into the computer, and some of our early products were to digitize the sound and became the first sound in computers, both for Apple and for later for Windows. And that became the sound format that's used by the internet now. And that how you get the sound in there, how do you compress it, how do you break it into pieces, how do you send it over the internet, how do you reassemble it and play it back on various kinds of input and output devices, so that you have both the voice and the data converging together into the internet. And this address a lot of the problems of how do you do music, which has become MP3, and how do you do streaming, which has become things like Skype or Zoom, which we're using now. And these are sort of the early applications of, well, what can you do on the internet in addition to just sending raw data back and forth. And so the internet has grown substantially, and people think of the internet as a inanimate, non-living thing that now connects several billion people. But if you think about it, important component of the internet is people. So the internet is made up of billions of computers and the connections between them, but it's also made up of billions of biological minds that are all connected together. And so it has some of the characteristics of a brain, which also has billions of neurons that interact. And so in my view, the internet is alive, that's made up of a combination of living people and the electronics that connects them.
And so coming to this idea that the internet is alive, how has that informed your work, and how can we look at the internet as alive? Like what implications does that have? And especially related to the evolution of technology and the evolution of life in general. Can you give us a little bit of a sense of the ecosystem when we're looking at the internet as a live organism?
So in physics, things are kind of deterministic, and most physics that people are familiar with, like Newtonian physics, you can predict very accurately what a system, even a complex system, is going to do, because the variability is relatively well predicted. And in biology, things are non-deterministic in that it's usually chemistry and water that has a certain statistical or probabilistic way of working, and that the complexity of it is even more complex because all of the components are changing. The chemicals react differently at different temperatures, and it's a multidimensional problem. And so at the basic level, physics is deterministic and biology is non-deterministic. And so the internet, in some ways, works as a deterministic system that you can predict how the electronics might work. But the people on the internet are non-deterministic in that it's much more difficult to predict how each individual is going to behave. And thus, when you have billions of individuals, it becomes even less predictable. And so it's a combination of a deterministic system with a non-deterministic system that makes an even more complicated system that is basically like a living thing that has the elements of life and biochemistry and has the elements of the physical world that it's in. But the combination is a lot like life.
So that leads me into the controversial topic that's really popular right now around the CRISPR babies, where the DNA was edited in the embryo. And the specific case that's being widely publicized right now is Lulu and Nana, who are given a gene mutation to make HIV harder to enter the system. And I'm curious, one, what your personal perspective on this specific case is, and perhaps even more importantly is, to tie it into also the internet being alive and us. It's not deterministic. We don't actually know what will happen. It's very complex what happens when technology gets in the hands of humans. And so I'm curious, when thinking about both synthetic biology and exponential technologies, what is the framework you use to consider its impact? What type of thinking do we need to adopt, and how do we best reconsider or rethink ethics? So your personal perspective on the CRISPR babies, just so we can orient to how you're looking at it, and then the more macro perspective of how do you think we should look at technologies, both synthetic biology and computer design and the whole spectrum, so that we can do our best to understand and think about the impact on both the earth and humanity.
Sure. Well, the designer babies, essentially, that are in the news recently with a researcher in China who has modified the DNA, the genome of fertilized eggs, which are when there's a few number of cells in an organism, it's easier to modify it using tools like CRISPR than when there's billions or trillions of cells, where if you're going to modify the genome, you have to essentially modify it in all the cells. And so when there's a small number of cells, like one fertilized egg, there's only one genome there, and it's easier to modify that. Or when it grows to 2 or 4 or 8 or 16, or usually around that stage, you would take out one of the cells and sequence it to see what the genome was in the other 15, and then make a modification tool like using CRISPR, which can edit or insert pieces of DNA into the main genome and change the number of cells that are there, which would be at that stage between 8 and 16 and 32, in that range. And that genome would be the thing that grows into the adult, or first the infant. And that research project, they used the tool CRISPR, which comes from bacteria, in that it is the memory and the immune system for bacteria, that how a bacteria recognizes a virus has infected it, knows how to chop it up in the future, and that biochemistry, those enzymes that come from bacteria, are what's called CRISPR, that can be used to modify the DNA in bacteria, of course, but also more complicated organisms like yeast or plants or animals like humans. And so this biochemical tool was applied by the China researcher to modify the fertilized egg, or essentially the early fetus of humans, to change the DNA of the human, not their adult DNA, but the DNA of every cell in the organism, which means that when that human develops and creates egg and sperm cells, those cells will also have the modification, which means the children of that human will also share the modification. And so that's called the germ cells. Essentially, you're modifying the heritable DNA. And in most parts of the world, this has been understood to should not be done for humans, in that modifying the human's genes in a permanent way that'll be inherited is like at the beginning of creating a new species that is different than those that have evolved so far naturally. And naturally is sort of a strange word when it comes to biology, because us choosing who to mate with determines a little bit the characteristics of the offspring. And that's natural, and that's how it's always been for humans and other animals. And that's called selective breeding. But the nature of that has human influence, and we can talk about whether human influence is natural or not. And so this CRISPR technique to modify babies, to make designer babies who will turn into designer adults that will have children that are also different, is considered dangerous, because making a modification might have unintended consequences, or it almost certainly will. And so in this case, these two infants were in their original sequence were determined to have a risk of a vulnerability to certain diseases, HIV in particular. And so the project was to modify their gene, that particular gene that exposed them to that risk. And it may or may not make them resistant to HIV when they're adults. But the unintended consequence is that same gene may reduce the risk for getting HIV, but evidently it increases the risk of getting West Nile virus. So on the one side, they've been modified for something that humans would see as desirable, but on the other side, that modification also put them at risk of something else that maybe the engineers didn't think about when they made that change. And other examples of this would be, say, sickle cell anemia, which is a painful disease when you're in a normal environment, and it would be useful to turn that off. But at the same time, it makes those people who have that resistant to getting malaria. So we would think, oh, well, we don't want to have sickle cell anemia, but those are the people that survive better in an area of the world that is infested by malaria. And so these kind of modifications, if you think about them narrowly, which evidently this research project did, can have the unintended consequence of maybe making those modified people resistant to certain diseases, but making them much more vulnerable to other diseases that weren't thought about at the time. And so the general scientific community has been, at least in humans, don't do this. That is done in plants, is done in other animals, but modifying the humans, we don't really have the wisdom to know what the negative consequences to what appears to be a positive modification are, and so it's considered dangerous. And this particular researcher who did this it's very controversial because most institutions, including in China, all agree don't do this kind of modification or this kind of research. And so in a sense, this particular scientist was kind of rogue. He was trained at Stanford and in the US, and was very well trained and educated in what he was doing. So it's quite possible that he did it. But the institutions, even in China, where he did it at, are now saying that he wasn't authorized to do it. In fact, he was apparently on discipline and discharged from the university where he did this in China. And it turns out about 9 months before it was announced. And so what happens after 9 months when you do something with humans? So the news is still coming out about this, but it's a controversial topic of it essentially playing with what is a human and using our limited wisdom to modify to make presumably a better human that you presume is going to do better in evolution in the future, but they may not, and they may cause other problems. And so this is a timely and controversial topic, and it's not clearly understood what the implications are. But some people would say changing the genomes of humans or even changing selective breeding parameters is like playing God, and that it's forbidden to do that because it's playing with the unknown.
And you said something interesting, which is around whether it's natural for humans to affect nature, biology, evolution. And when I've studied biomimicry, there's often a separation between looking at nature to inform how we might design, and then not considering the human as nature. And one perspective is that we're not separate from nature. And so I'm curious how you hold our impact on evolution, or evolution's impact on humans, and how that might relate to how we look at innovative technologies. So with this project that just happened, are you one to say, well, we need to experiment and innovation's not inherently bad, and everything's a little bit mysterious and uncertain? Or are you one to take the more certain route? And so I'm just curious how you hold this.
I'm more in the uncertain category, but the humans are definitely nature. That there isn't a part of humans and their most extravagant intelligence and most fantastical creations that are not a product of nature, because humans are nature. And so, the internet or the space station is something that has evolved from nature, and it's evolved from humans doing things. And so all of these kinds of things that we're experiencing are products of nature and subject to natural selection, just as any other living thing is. And so whether the space station helps us evolve into a more stable species or causes us to go extinct, it's an uncertain gamble on our part to do such an innovation, and the consequence of that can't accurately be predicted easily. And the more complicated it is, and the faster it happens, the less predictable it is. And so modifying a human or inventing a space station could lead to a negative natural selection consequence for people. And so if, say, a virus or infectious disease evolves on the space station and then gets back to Earth, it could wipe out humans. And that would be an unintended consequence of making the space station that wasn't easily predicted from doing that. And so these kind of unpredictable futures, especially as they relate to the combination of technologies and humans, is where the concept of a singularity comes from, in that the singularity as a term comes from physics and was originally described as the falling into a black hole, where physics happens in a predictable way when you're far away from a black hole, but as you get closer and eventually fall in, the formulas that you use to predict things become inaccurate, and the result becomes unpredictable. So what it's like to live near a black hole, where there's one at the center of our galaxy, is normal for us. But if we were to fall into it, there isn't anybody who could accurately predict what that would feel like or what would happen when that happens. And so this accelerating falling into unpredictable change is a little bit like these kind of accelerating change in evolution and the things that we invent. What the consequences of that are unpredictable. And so we have this term singularity that says falling into an unpredictable future. And that's happening faster and faster. Doesn't mean it's bad, doesn't mean it's unnatural. Doesn't mean it's not subject to natural selection as sort of survival or extinction. But it seems to be happening, and the result is unpredictable.
You said something interesting when we spoke earlier to prep this call, which was that, even though the scientists made the gene edit, the DNA edit, it was ultimately nature that chose whether it was going to work or not. There was still natural selection as part of it, yes?
Absolutely. And that's, in that case, it's nature will decide in the future whether that was a good idea or not. And the early predictions can be even 50-50. Some people might say it's a good idea, and some people will say it's a bad idea, and try and predict why. But we won't know for 18 years or 100 years what the result of that's going to be. And so that's the dangerous part, because if the result is really bad, then and affects billions of people, then that was obviously a mistake. But we won't know in advance. People can use their scientific intuition, but generally science is trying to predict things that were previously unpredictable. And so when you're playing at the edge of things like modifying human genomes, the results are unpredictable, which makes scientists and everybody uncomfortable for obvious reasons.
Yeah. Before we move on, I'm curious to hear from those of you who are here, if you'll write in the chat box, what is your perspective on the CRISPR babies, or just on these more controversial, edgy innovations that people are making right now? Are you someone that wants to play more in the certainty, a little bit more safe, or are you a fan of let's play in the uncertainty, let's see what's possible? If you want to share in the chat box, and if you're listening to the recording, just take a moment to think. You could even pause this. And I think it's important that we all really take time to reflect on what our positionality is on the different things that are happening on technology. You don't need to know the answer. No one knows what's right or wrong. It's not even about that. It's just about actually taking a moment to really consider what our position is on it, or how it makes us feel. You use the phrase scientific intuition. And as amazing as science is, and data and mathematics, and it's so important, there's also this intuitive aspect that we all have that sometimes doesn't make sense with the data, that can often give us very powerful cues of whether to move forward or not. So if you feel called to share, just we'll give everyone a moment to jump in there. And I know this is something that can take more than a few moments to consider if you haven't already thought about it, because there's so many variables to consider. And maybe while people write, Reese, what is a way that is there a set of indicators, or are you looking at your intuition? How much do you use data versus intuition to really think about some of these more controversial topics?
Well, there's another path of describing biology and life, is that life is information, and information is kind of data. And when we look in a forest and look through the leaves and we see a little change in the light, our intuition would tell us, oh, well, that's either something we can eat or something that's going to eat us. And so if we didn't evolve to look through the leaves and notice that might be a tiger walking by there, the people who didn't recognize that got eaten, and they didn't breed, and they're out of the gene pool. And the people who were able to recognize that, or other animals, survived and bred. So the kind of characteristics of what our intuition, or what our data noticing, or what we can detect and predict, is something that has evolved by natural selection, and the way it works is the information that came from the data of looking at the light through the leaves triggered maybe a long structural memory from our ancestors that if you see something like that, run away, and so that, or if you see something like that, go eat it. So either way, it's information, and so the information is running our intuition, and our intuition is based not just on the data that we see now, but our sort of ancestral heritage, results that led to us as to what's good, what's bad, what do we react to, what do we ignore. These things are evolved. And so in a simple description, life is information, like how the information is flowing through us, and the information that came before, and even the information in our genes is something that you can convert from the biochemical information that's there into computer data. You can change it in the computer, and you can write it back out into DNA, which is what this CRISPR approach is about. So it's information either way, whether it's in visual form or DNA form or ideas, and that the information is what's evolving, and that is life.
Right. Life is ultimately a feedback loop of information. And sometimes we get immediate feedback, which can actually show up as feelings. We might create something, iterate, and then something might feel off. And so just to listen to all those feedback loops, and there's so many different types of information available to us, from the emotional to the data, that whole spectrum. So I'm going to read. So Manuel says, I really don't know. This is in response to, what's our perspective on the designer babies. I really don't know. Change is natural. So if we die because of a mistake of several people on Earth, then that is our future. certainly one perspective to take as, we can't really do anything wrong, that if we're able to do it, then that's part of our evolution, and it's part of our life's journey, and what will be will be.
That's almost certainly correct.
Right. That's a lens that can encompass all of it. Right. It can hold all of it.
Yeah, and that's sort of a Zen acceptance of what will be will be.
Is that a perspective that you tend to lean into, Reese?
Yes. Yeah, because the alternative of saying we're going to control anything or everything is unlikely to be true. Mm. So you can either go with the feeling and the life purpose and the illusion that we're in control and we have free will and we are going to guarantee the outcome of this thing in the future. But there are many ways that assumption can be wrong, and that our illusion of control and our illusion of the ability to control things might be incorrect, and that the unintended consequence might be good or it might be bad, but it's certainly not perfectly known.
And so when we think about life will be as it is, and perhaps we have much less control than we like to think as humans, then how do you think about making change in the world? I mean, you've been involved in so many projects and in so much innovation, including co-founding Singularity University, being a trustee in the Santa Fe Institute, which we'll get more into. So you're very involved in making positive impact in the world and educating the world. So you're holding that perspective, but you're certainly in action. And so how do you navigate your life? And is there a sense of urgency in you of like something needs to change or happen? Or are you involved in all this because it's fun for you? What's your motivation in life to be involved in so many projects? And if you could talk to us a little bit about how we might all hold looking at making a change and what needs to shift in the world, or if you think anything even needs to shift.
Well, I think, so first of all, what motivates me is these things are fun. Complexity is fun for me, and change is fun for me, and the combination of those two is even more fun. And so that kind of directs what kind of projects I pay attention to. And for example, I learned that I like the early beginning stages of new projects and new companies much more than after they're already mature and established and routine, in a sense, in that the weekly budget meetings are less fun than new ideas sessions for me. For some people, it's the opposite. So that's why you have a team. But the how these directions, like how we impact the world, I think some of these organizations are to show people and teach people about how the natural flow of these changes happen, and that if you can recognize the flow of change, you can interact with it in a much more effective way. So, for example, if you see the flow of a river, for example, and you want to impact that river, if you're trying to do something that changes the direction of the mighty river's flow, you're less likely to have an impact than if you're flowing in the direction of the river. And so by recognizing some of these flow of changes and trying to align your impact that you're trying to have with them, if you're going with the flow as opposed to resisting the flow, you're more likely to be successful and less likely to be frustrated. And it doesn't mean there's not some value in disrupting flows, like a beaver disrupts the flow of a river temporarily while it's alive and it can maintain its dam. But once the beaver kind of lets go of that dam goes away and the river is, back to the way it was, maybe modified a little bit. And so the impact that we have, it to be happy in life is having impact that's kind of consistent with the flow of and change of things, as opposed to trying to stop it. So there are people who want to resist these changes, like resist technology, resist the river, that kind of thing. And there's plenty of psychological reasons why that might be. it may be more frustrating for taking that path than something going with the flow.
Hmm. So when thinking about creating new projects that have positive impact, I kind of extracted something that you didn't quite say, but let me know if this is accurate. It seems that we might have more impact if we're working on something that excites us, rather than just thinking it's because it needs to change and forcing ourselves into it, but actually doing things that are exciting to us.
Yes. Yeah. Well, if something needs to change, that if you're passionate about changing it's you're going to be more successful than somebody who doesn't care, and it's just their job. Yeah. And so that kind of choosing what you want to work on based on what you're passionate about leads to more life satisfaction than doing something because you have to. But then again, if you have to do something, accepting that you have to do it and doing it well is a better path than resisting it. So these, so as far as what projects to start, being passionate is of course valuable, and you have to ask yourself, well, why are you passionate about that thing? Like, why do you want to change this thing? What's motivating me behind my consciousness to take on that project or change that thing or solve that injustice or change the world in some way? Well, why do I want to do that? Like what's behind that more than making the change itself?
Yeah, that's a powerful inquiry. What's our why? It's our guiding force, right? That keeps us going, especially on those harder days. And so also with the flow of river, not going against the river, but actually flowing with the river, oftentimes people are looking at the systems in the world that are broken, disrupted, needing to completely change. And so there's a resistance that happens. And I'm curious how we might look at innovating in a way that doesn't resist, but actually goes with the flow, but redirects the current. For example, with our food system, there's so many things wrong with it. I mean, many systems of the world have many, many factors that seem totally anti-nature, that are killing us, that are killing the earth, that don't make any sense in so many ways. And so I think the natural desire is to totally break it, stop it, resist it, and create something totally new. And I'm curious if you have a different perspective of what does it look like to think about innovation that's flowing with the river rather than against, but maybe just creates a new tributary.
Yeah, or going around it. It's so these are it's sort of the concept of complex systems that evolve and can get kind of they in a way stabilized, but in a way calcified. So if you have a complex system like a government, it builds in sort of internal structures that make it harder to change, that keep the status quo going, and the calcification, like becoming more rigid and unable to change. And so you can try and change such a system from within it, which is intrinsically built to resist the change that you're trying to make. And Buckminster Fuller has this cool idea where if you're confronted with a calcified complex system that is difficult to change, you don't try and change the existing system. You build a completely different one and go around it, like a tributary, as you say. That it's easier sometimes to build a completely new system without the calcification and maybe without some of the benefits, but it's at least it's more adapted to the new environment as opposed to the old system that maybe evolved in the old environment that's now changed and may not be optimal for the way things are now. So building a new system, like a new species or a new life form or a new way of government or a new way of food distribution or healthcare, is something that may be better done as a completely new system going around the existing system, as opposed to breaking apart the existing system and trying to tunnel through it with a new system.
So while we're on this topic of making change, I'm curious, what are the 3, 1, 2, 3, however many you'd like to share, really, most crucial shifts that you feel need to change if there's so many different systems, and if you saw one radically changing, would it change all the others? Or where do you think is the best use of our energy to create new systems, new tributaries?
Well, the overriding biggest one globally, from my point of view, is this distinction between dualism and non-dualism. In that a lot of religions and a lot of governments and a lot of people operate in a dualistic view of the world, where there's good and there's evil, and there's inside and outside, and us and them, and that an artificial distinction is created based on some random characteristic, like the color of people's skin, to say, well, there's us and there's them, and that the us and them creates then a conflict and creates a way to divide things and separate and battle each other, essentially good versus evil. And so a non-dualist view, which would be everything is connected, we're all part of the same system, we're all kind of on the same planet going through space together, that we should be cooperating because we're siblings or we're cousins, including with the plants and the mushrooms and the fish and so forth, that we're all part of the same family, and we need to be cooperating as opposed to fighting. And so that kind of thing applies not just to religions and governments, but to our personal lives and the kinds of businesses that we do, in that we're part of an ecosystem and not a fortress against an enemy.
I have found this to be a life-changing perspective that I hold for myself, and really looking at the world as one ecosystem, one family, one nation. And if we brought that perspective into every system, government, food, healthcare, I think everything would be approached much differently.
Yeah. And part of that is acknowledging that people aren't the ultimate outcome of everything, that we're part of a system, and most species, 99% of species that ever existed, are extinct, and in all probability people as they are now will be extinct at some point in the future. And it doesn't mean that life will end, it means it will be different, and we're changing into that difference, and how that affects our species is one thing, but the probability is this species as it is now will no longer be here. But something may be better, or maybe certainly different, possibly will be. Hopefully we don't extinguish all biological life on the planet, although that's possible. So but the thing is if we're sacrificing self, or sacrificing a species or some subset of it, that's it's part of the evolutionary process, and that and it's a little bit like going with the flow of the river in that direction.
Yeah. One of the teachings I could pull out of what you just shared is looking at our own life and seeing where we're stuck in a certain way, perspective, belief, and really looking at how we can be more adaptable, where we can make change to pivot with the flow of evolution that's happening around us, rather than trying to keep something the same, because life wants to evolve. And I believe that we can consciously evolve our own lives and also the whole planet. And so as much, it kind of comes back to whether we actually are the catalyst in designing for evolution, or whether it's happening with or without us, and what part we play in it. But I do feel that if we take the lens that, of design thinking, where we do have some influence of our own life and evolution, and the impact that we make on the entire ecosystem around us, it has us moving with the flow of life, rather than, I guess we could distinguish between moving with the flow of life and not resisting it, versus letting life just happen to us. Right? Moving with the flow does, for me, I find in there, there's still some intention, some focused, aligned action, rather than just letting life fully happen and surrendering to it and being complacent. There's a distinguisher there for me.
Well, and that's that's good thinking. There is a important characteristic of life is controlling certain things. So like cell membranes or our skin is trying to control what's inside the skin versus what's outside. And so it's a fundamental element of life to have some level of control, because that is life. So you can't completely dissolve your skin in your cell membranes and become one with the universe, or you will eventually. But while we're sort of a conscious, functional being, there is somewhat this dualistic concept of the inside and the outside, and how you come to accept that, and that, in some ways you're sort of fighting with the entropy that is dissipating our physical being, and on the other side, that's an inevitable thing that if you accept it and are grateful for the circumstance that we're in right now, but also not resisting or not afraid of the dissolving into everything else, then that's an interesting way to think about life from a personal point of view.
I mean, we've touched on two of perhaps life's most deep inquiries: duality versus oneness, and whether there's separation or everything's connected, and to what degree are we all connected in one organism, and to what degree are we separate? And then also, to what degree do we control, and to what degree do we surrender? And there's no right answer, but I really encourage everyone listening that if it's not already a persistent inquiry, a lens that you're considering, I invite you to go into it, to explore that dance of those both, because I have found it very enriching. My lens for which I look at life has expanded. I'm able to hold more perspectives because of just looking at those two and knowing, all right, how much discipline and action and control do I take versus how much do I just allow? And sometimes one calls for more, right? So just something fun to play with. And there's so much we could jam on, but we're coming near an end. So I want to pivot to Singularity University. I'm curious, what inspired you to be a co-founder in this, and what purpose does it aim to serve?
Well, so Singularity was the original concept came from Ray Kurzweil's book called "The Singularity is Near," and that's sort of the underpinning, like, original textbook of it. And then Peter Diamandis, who had started the X Prize and something long ago called the International Space University. And the third inspiration was TED, where basically Ray and Peter met at a TED, and we're talking about Ray's book and Peter's way of organizing teaching things like Space University and X Prize. And so the inspiration was TED, but with the topic focus of Ray's book, and then the structure of Peter's type of structure. And the basic idea is to teach people how to recognize change in technologies that change fast. And then if you learn to recognize those, you can then use those technologies that are changing fast at this exponential pace to solve problems. And that if you solve a problem using something that's naturally changing, your solution to that problem will naturally get better without extra work. So, for example, phones get twice as good every year, and if you use a phone to solve a complicated problem like water supply or poverty or something of that nature, your solution to that problem will naturally get better as the phones get better, and that you can therefore affect problems at a larger scale more quickly. And so Singularity tries to teach people to recognize these technologies, learn how to solve problems with them, and then scale the problems. And the definition of a problem solving is how do you affect 1 billion people within a 10-year time frame? And that seems impossible in a sort of linear technology way. But as technologies accelerate, you can reach more people because of the exponential technology than you would if you were approaching it in a intuitive, linear way.
Yes. So Robert has a question that he actually asked before I queued up this, and I think it's relevant for Singularity University. How can we use tech to accelerate the union consciousness in the world? So how can technology help with moving from duality to unity consciousness? Is that what you mean, Robert? Yeah.
So Kevin Kelly, who started Wired and is a accomplished author, has a concept called the technium, which is the evolution of, in a sense, the evolution of complexity. In that biology is complicated and it's evolving, and technology can become complicated and it's evolving too. And that things like the internet and biology are both evolving in parallel and independent of each other. In that it's in a sense the complexity that's evolving, in that both the technology and the biology are part of the same system that is collectively evolving on this exponential path. And so there's things you can do with your hand that are biological, and then there's things you can do with a tool that is technological. But in most cases, your hand is operating the tool, and that the tools are improving and the hand is improving, and then the system of a hand with a tool is evolving as a combination in nature by natural selection. And so the technologies are essentially part of our biology in the same way as any tool is. And so some species evolve to the direct manipulation of their physical environment, but then they develop claws or teeth or something that are in a sense a biological technology that helps solve problems. And the we and other species are evolving tools like hammers, and then things like fire, which is a natural phenomenon, but developing the technology to control the fire, we can then heat houses and cook food and other things. And so Sundar Pichai, who's currently the CEO of Google, has an interesting concept that first came fire, then came electricity, and the next evolutionary invention is AI. And that, in his opinion, AI is a more important evolutionary step for humanity than either fire or electricity. But certainly the combination of them is sort of a moving not just humanity but life to another level of evolutionary complexity. And that there isn't a distinction between life evolution and technology evolution. They're the same thing.
So the Singularity University is looking at exponential technologies and using them to solve global challenges, and looking at a new way of thinking about technology and its role in the world. And then another project you're a part of, the Santa Fe Institute, from my understanding, is an interdisciplinary institute for research of complexity science.
Yeah.
And it's looking a lot more at nature, ecology, biomimicry, how ecosystems survive, and what nature has done successfully. And I'm curious about how you look at the integration of the two, how the Santa Fe Institute's research is informing the technology research and education that Singularity is sharing. And perhaps, what you just said is that these things aren't separate. So is that inherently built into Singularity, or is it much more technology focused?
What is that built in?
So looking at nature, ecosystem, ecology, the research that the Santa Fe Institute is doing, is that type of research inherently kind of built into the exponential technologies of Singularity?
Yeah, they both cover the same kinds of things of nature, and that Singularity focuses a bit about the technologies and solving problems, and Santa Fe is more the theory of complexity and how it works, sort of a general theory of complexity. And so nature and life is complex, and understanding how that works is important. And then how do you affect it is more what Singularity is doing.
Got it. These are two amazing projects. I encourage everyone to look into Singularity University and the Santa Fe Institute, which we'll link in the show notes. But you could spend hours on either of those sites with resources and reading. I mean, I encourage you to go often and get your little weekly boost of inspiration. And it's the type of research, from my experience, it's the type of research and writing that really isn't just teaching you, like telling you something, it's presenting things that have you open your eyes a little more, that have you expand your perspective of how you look at life. And even you, Reese, when I look at your Facebook and everything you share, you're not providing opinions or what you think. You're actually just presenting what's happening. You're offering people resources to look at and to make our own decisions about them, or to just, we don't even need to make decisions sometimes about things. The habit, it tends to be so much of like, let me compartmentalize this into right, wrong, good, bad. And there's so much happening in the world and so much innovation around technology and everything that I think it's good just to be aware. And on a really personal question, I'm curious, how do you filter reading and articles? I mean, just looking at your Facebook page, you're posting things all the time. And I'm curious how you approach your own individual research on a day-to-day level. Like, how do you choose what to read? How do you go about receiving information and data? And then what do you do with it in your mind? How do you let it inform you?
Well, I have a sort of theoretical model of how the world works and which way the river is flowing. And then I like to scan very broadly across the internet things that are representative of that, and then post those. And that to sort of let other people see, which way the river is flowing, and make their own decisions about what's important from that or not. But it's kind of a meditative practice for me, watching the river of the internet flow by and pointing out the cool stuff.
Awesome. And just one more question before we wrap up. If you could share one message with the world, so let's say all the most influential leaders got together to share one message that you felt was most vital for people to know right now or to have in their consideration, what would it be?
We're all in this together, and we need to cooperate.
Hallelujah. That is a good one, and it's a good place to end. Thank you so much for taking your time to be with us. And I acknowledge there was a couple questions that went in the chat box that we didn't have time for. So if you're open to it, Reese, maybe we could just ask you one more question, and we can end the recording or not. Brian, you can decide. But if you have a couple more minutes, I'd love to get Robert's question in here from earlier, and also to honor everyone who expects this to be an hour call. So for everyone who's been here, thank you. It's such a pleasure to connect with you all from around the world. And if you're up for one more question, does that feel okay, Reese?
Yeah, thanks. No problem. Yes.
Okay, great. So we'll just dive into that really quickly, which is from Robert. What is the role of scientific intuition tapping in the realms of quantum physics in the world of AI meeting biological human evolution?
Well, so quantum physics stands out as a question there, in that physics, that as most people are taught, it covers kind of the middle range of phenomenon, the not too small and not too big. And it's fairly accurate at predicting that. But when things get small into the quantum realm, or very large into the cosmology or astrophysics realm, the regular rules of physics don't work so accurately. So you have to develop new language to describe the very small or the very large. And so to have good scientific intuition, you have to have some exposure to all three realms, small, medium, and large. And that helps you get a sense of something in the middle range is going to behave a certain way. And if it gets smaller, there's a slightly different language that's more accurate to describe what's happening, or at the other extreme, like black holes, to understand what's happening. So there's sort of an example that science stops talking about things at either extreme, and they become sort of esoteric areas to analyze and to try and figure out. And the intuition even breaks down because they're not behaving in a similar way. And so that's sort of how the scientific intuition went. And what's the other part of the question?
The question was really just using your scientific intuition to understand physics and how it relates to AI and, biological evolution.
Well, so AI is essentially machines learning things, and there's a real simple way to think of AI is that when it doesn't exist yet, when it's theoretical, it's called AI, but as soon as it's used in commercial products, it's called software. And that it's something like AI is a little bit of a mythical thing, and that it's essentially the machines becoming smarter like people and having the ability to learn and have memory. And so in that sense, they're becoming more biological, and that the AI is something that is behaving more like people, and that at a certain point, though, people are biological and they behave in statistical, stochastic ways. And so AI that's programmed in a very rigid way isn't really much like natural intelligence. It's very good and very fast at very specific problems, but natural intelligence has to have a squishy, watery part that allows it to adapt and change and apply the rules that it's learned from the memory to new, novel kinds of problems that it hasn't seen before or anything like it before. And that becomes more like natural intelligence. And so AI, its history actually is there's both artificial intelligence, but also augmented intelligence. And so I'm more a fan of the augmented part, where AI with humans involved is like a more useful combination than either by themselves.
Mm. Awesome. Thank you so much for taking a few extra minutes. It's been so amazing connecting with you. I'm very grateful. Thank you for joining the Hive community in this way. And to everyone who's been here, it's been such a pleasure. I can't wait to be with you all next Wednesday. And thank you for showing up in your leadership and being committed to creating a better world. We're just getting started. And like Reese said, we're in this together. So that's why we gather as a community, because we're more powerful when we do this together. So thank you. Have a
Thanks,
beautiful
everybody.
day. Bye.
Bye.
Thank you, everyone, for being here.
Thank you.
And great questions, Robert. Thank you so much. Yeah. Bye-bye.